Okay. Page, you'll write reflection, and then you'll have bless you. Oh, don't die. Steady there. You okay? Okay. So then you'll have a header. Part 1, for instance, A. Kid was solving this problem. If you have a picture of that kid's work, you'll put it here, right? Insert image, straight into document, okay? If you have the actual scratch work, I don't want you to necessarily attach that original piece of paper. I want you to embed the image in your write-up, so I don't have to flip around all the pages, okay? So like, pic of kid's work. Okay? Part B. I asked this question, and he said, blah, 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 right? Because part B is supposed to be the explanations you elicited when talking to the child, meaning, what did you get the kid to tell you about their thinking? So this is where I warned you, right? If all you're doing is explaining to the kids how to do stuff, you literally shot yourself in the foot, because then you're not going to have anything to write here, okay? So this is where you tell me what you got the kid to say they were doing and thinking in part B, okay? Part C is where you actually analyze their thinking and their mathematics using all of the stuff that we've discussed in this class, okay? And so this is where you would say things like, oh, okay, so let's pretend that the kid counted out 3 pom-poms and 5 pom-poms, right, by doing the following. 1, 2, 3. 1, 2, 3, 4, 5. Smush them together. 1, 2, 3, 4, 5, 6, 7, 8. That's what the kid did. Okay? So you might say something like, okay, so this child could be thinking about numbers in terms of cardinality. Might not be thinking about numbers in terms of cardinality. So what do I mean by that? I mean, when the kid is going through the action of saying 1, 2, 3, 4, 5, 6, 7, 8, he's counting, right? But I don't get the impression that he's thinking about that entire group as collectively being 8. It's almost as if he was using them to count along, and then he finished using all of them, and he was at the number 8. So that's what he's going to say. Does that make sense? What he did, but then, so using my big girl words. Now, I wonder, what do I wonder? If I gave this kid 2 plus 8, would they do the same thing? Or would they maybe count by 2s instead? 2, 2, 4, 6, 8. And then go 2, 4, 6, 8, 10. I don't know, maybe. That would be an interesting thing to find out, right? So this is something I'm pondering based on what I've seen the kid do already, right? I know the kid can count by 1s. Now I wonder if the kid can count by 2s. Would he not be able, because of course he'll be able to, just would he count by 2s? Right? Because in particular, one of the things that we're interested in as children progress in their mathematics is they start out by counting by 1s, and then maybe by 2s, and then maybe by 3s, and then like by 5s, and then by 10s, and then by 100, right? This is the natural progression of how we teach kids to count. So this would be something I would be curious about, right? And then another thing I'd be curious about is if I maybe designed a task where I told them like, okay, rather than, okay, so the reason this kid was able to do what he did in terms of like smushing everything together and going 1, 2, 3, 4, 5, 6, 7, 8, right, is because I provided tools in a discrete setting, right, individual pom-poms. But what if instead I had like a piece of paper that measured 8 inches and a piece of paper that measured 3 inches? And I don't give him a separate ruler, right? And that's all he has. So I've got one paper that's got like 6 tick marks and another paper that's got 3 tick marks, right? And I say, okay, how many tick marks? Or how long is this paper, right? If I put them together. That would be an interesting way for me to see if this kid could think about counting off, right? Could they imagine starting with the 8 as an 8 rather than having to go 1, 2, 3, 4, 5, 6, 7, 8, right? But here's 8 already, 9, 10, 11, right? And so now I'm thinking, okay, if I change the type of manipulative I have, could I help this child like advance a little bit more in how they're thinking about counting and addition? Does that make sense? So this analysis part, C, is where you're demonstrating to me that you're thinking critically about the progression of the child's mathematical development. So here's the basic task that I gave him, but that basic task is the first step in a long sequence of things that this child is going to eventually understand and do, right? And so this is your chance to show me like, okay, well, it's because of the manipulatives I brought that this was an obvious way to do it, right? But I wonder if I had switched out my manipulatives, what other pathway might he have chosen? Or if I had asked this other question instead, then I could test my hypothesis about, the counting by ones thing versus counting by twos thing, or something like that, right? So this is where you conjecture and you propose like all of the cool things that you're thinking about that are related, right, to basically everything we've talked about in this class, which includes the mathematics and the representation of that mathematics. Is this like sparking all kinds of things in your brains right now? Okay. So once you've done that for the first instance, then you'll create second instance, right? Part A, Part B, Part C. Please, please, please do not mash this into like a 5-paragraph essay. You will just destroy my Thanksgiving break. Okay? Just please make it obvious for me to find the parts that I'm looking for. Okay? And so likewise, in Part 2, when you're analyzing your own mathematical thinking, I have 2 parts. So you're going to have like a heading on the next page, Part 2. A, comma. And now you're going to tell me about each person's thinking and how it progressed related to the mathematical content that your game was designed around. Okay? In particular, when I ask somebody to tell me how their thinking has changed, that means you must tell me how your thinking started and then how it ended, right? You can't just tell me how you're thinking, because that's not telling me a change. So you need how you started out thinking about it, and then how you finished thinking about it, and then highlight what the big evolution was in your thinking, okay? Now, if you can do this, so the reason you're in groups, right, is because doing this kind of thing is challenging, as is doing the analysis of the children's mathematics, right? You're in groups to be talking to each other. This is not meant to be an individual activity where you're like, okay, Susie, go write part A, and Jenny, write part B, Bob, write part C, right? That's not what this is for, okay? If you're not talking to each other, you are not fully taking the opportunity that I'm asking you to work together with another future teacher thinking about kids' mathematics and your own math, talking about it, right? The whole point, okay? Question?
So for that part, should we put it like, this is like Carly and that, like, should I put like rating, like not thinking, like Carly and
Yeah, you could. And then if you notice some overlaps or commonalities between them, then you could find a way to maybe blend the stories. right? Like if you each had the same way of thinking to start with and ended with the same way of thinking because you did this activity as I suggested where you were working together the whole time, then you could blend the stories, okay? But I anticipate even if you started out thinking the same way and ended with similar ways of thinking, there was probably different avenues through which you got there because you probably noticed different things while working with the kids and whatever, right? So I'll leave that to your discretion, how you want to write that, right? And then what connections to other mathematical ideas? So you each had mathematical ideas that your games were supposed to address, like you listed out the Common Core standards for mathematics that your game addresses. And now I want to know, in particular, that you might have done this in the moment when you were at Gift of Numbers, but you might not actually have done this yet. And this stuff, connections to other mathematics, will come when you're doing the analysis up here, right? When you're pushing yourself to think about, I wonder, right? If somebody's thinking about addition in this way, will they be able to understand multiplication as repeated addition? I wonder, right? And so then you can start seeing how you can build, okay? And then the last part 3, is where you get to reflect on your learning goals and your experience. So in particular, in your proposal, you were supposed to have stated learning goals for the game, right? What were your learning objectives? And so in part A here, you should be able to tell me whether or not you think you met those goals. Yeah? And then, so if you wanted to make my life a little easier, you might repeat some of the goals here. Be like, well, I had this goal, like learning objective of blah. We did not meet it as we anticipated, but that's okay. But here's what I would do in the future. Oh, well, okay. Part B will be, here's what I would do in the future to modify the game so that I could meet that objective, right? So part A, if you say no, that's okay, right? Because in part B, you can tell me how you would modify your activity so that it would meet those learning goals, okay? And then part C, what you learned about working on mathematical activities with kids, teachers, and parents by participating in Gift of Numbers. I love parents to death, and they are so important, but man, did I see some parents getting, like, over-involved, right? Like, taking over for the kid, and I was just like, oh, let them do it. So anyway, so you hopefully learned a lot. This part C is where you get to do what I hope all of you, so my hope is that all of you had the experience like, wow, that was really cool. Like working with kids was awesome. That's what I hope you felt that night, okay? This is where you get to say that. That comment does not belong anywhere else, okay? I know it's so tempting to say that right at the beginning, like, yay, I love the Gift of Numbers. Kids are awesome. I believe you. I know that. I don't need to read it 27 times, okay? So I created a space where you get to say that kind of stuff. Please save it for that space. Okay. So those are my comments about your Gift of Numbers reflections. Are there any questions? Hopefully you've already started. My other recommendation to you was that you should have started writing it sooner rather than later because you should be turning in college level writing, which means I'm going to be checking for spelling and punctuation and grammar, right? These things are actually important in communicating with people. So 9 points out of your proposal is dedicated to just that, your writing, okay? And then, oh, I need to do that still. Okay, so there's one thing that I need to post on Blackboard, and that is a form where you get to, so I'll have a form on Blackboard where you're going to evaluate your group members' contributions to the project, okay? Do not include that in your package. That's going to remain anonymous. In terms of your group mates won't know what you said. Does that make sense? Okay? Yeah.
I know how you said, like, to even go to like, revise it or write it. You go to the writing center, just
Yes.
put our revision in that.
I just want the final polished version. Yeah. Mm-hmm. because they will sit there with you and like, no, you don't have to, but I recommend it.
For part 3, do you want us each to have one reflection or?
Nope, this is still a group reflection. Okay? Cool beans? Everybody have we know what's going on? Okay. All right. As always, I have grand goals for the day. But let me just, have any of you been paying attention to this thing that I posted online? This is the tentative schedule for the quarter that I reserve the right to change as necessary. I have to change it. It is now necessary. Okay? Because today so last time I had hoped that we had already started talking about integers. We didn't get that far. That's okay. But there's this other stuff about exponential things that I'm supposed to teach you about. And what I think I'm going to end up doing is switching the order of this. So today we're going to do the integer stuff. Tuesday we're going to introduce some number theory. And then on the last day we'll have a really brief thing about exponents and some review for the final exam. Okay? So that's the plan. And yeah, that's the plan. Okay? So, let's get into it. So the concept, the main thing that's going on today is that we're going to be talking about integers. So on the handout from Tuesday, the back side of the handout had all of the integer stuff. Let's see. Who else wasn't here on Tuesday? Destiny, I think you were not here, correct? And you were not here? Anybody else that wasn't here on Tuesday? Need the handout? Okay. So there's a lot of information in this chapter. But I think it's pretty friendly information, okay? So in particular, we're going to go through talking about different ways to think about signed numbers. So up until now, we've occasionally mentioned that there are negative numbers, but we haven't really talked about how to think about them, right? We haven't actually addressed that elephant in the room. We're going to, okay? And then once we do that, then we're going to explore different ways that kids think about signed numbers and talk about models or how we could introduce them in class and work with them and help or children develop understandings of them. If we're lucky, we'll get through the rest of that, but we'll see, okay? These are the main things that I want to make sure that we cover. So, let's just dive in. So the first thing that I want to talk about are 3 different ways to think about signed numbers. And so the first thing so this. Up until now, we've only been working with non-negative numbers, so 0 and bigger. So we're presuming that at the stage where you're going to introduce negative numbers to children, they are already familiar with 0 plus, right? Okay? Which means you have something to build off of. You already have this much of the number line, right? And so one of the first things that people typically do when introducing signed numbers, i.e. negative numbers, is say, okay, well, we have this half of the number line. If I were to think about, instead of moving to the right, moving to the left, right, I get the rest of it, okay? But in order to denote, what happens as we move to the left, I use a negative symbol in front of each number. Okay? Now, let me actually, I went too far. Let me put this up so that we can actually do a concrete example. What was the number I have on your worksheet? I think it was the number 2. Negative 2? Okay. Okay, so let's go through 3 different ways to think about the number negative 2. So if I want to think about negative 2 as the opposite of something, what should I be thinking of it as the opposite of? Okay, so I could think negative 2 is the opposite of positive 2. In particular, if I think about positive 2 as the distance between 0 and 2, I can make that a directed distance where I think about like going from 0 to 2, right, as a leap. So I'm jumping 2 units to the right. So if you actually prefer that, you could, instead of maybe drawing one big arrow, you could also draw like a bump to the right. Either way, okay? But now, if you want to represent negative 2, you're going to do the opposite. So you're going to go bump to the left. So this will be positive 2, and this will be negative 2. Okay? One of the most common things I see people struggle with when I ask you to, like students to interpret the meaning of a negative number in terms of opposites, they tend to like reverse the statement. So let me just say one more time, right? If I ask you to tell me the meaning of negative 2 using the opposite view of signed numbers, the sentence should start with negative 2 is the opposite of, right? Okay? The most common error I see is 2 is the opposite of negative 2. Well, I wasn't asking about 2. I was asking about negative 2, right? And so the order of matters, okay? All right. But this is not the only way. Another way to think about negative 2 is that it is the additive inverse of positive 2. What is an additive inverse again? So an additive inverse of a number is the number that you add to the original to get 0, right? So in particular, if I want to say negative 2 means blank in terms of additive inverses, then I would say negative 2 is the additive inverse of positive 2 because 2 plus negative 2 equals 0. Now, how do I represent that on a number line? Well, I'm realizing that this is actually being not useful at the moment, so let me... Blue. Maybe it'll do that. Cool. Why does it make it blue? I guess I don't get to do what I want to do. Okay. So in order to model this on a number line, what I still want to show is, okay, I've got 2, but if I add negative 2 to that, my net result is 0. Do you see that? So if I represent 2 from 0, right, because we're thinking of 2 as the distance from 0 to 2, then negative 2 is the thing that gets me back to 0. But wait, there's more. So the third way to think about signed numbers is as directed changes. So what do I mean by that? So I mean, in the case of negative 2 can be thought of as a change of 2 units to the left, starting from anywhere, any position. So in particular, most people initially think about negative 2 starting from 0. So I've got 1, 2 this way, right? So negative 2. But guess what? If I were to start at negative 4 to negative 6, that's a change of negative 2. If I capture that information. Or negative 2. Or negative 2. Or don't have to start on an integer value, right? I could start from anywhere. So it's this idea of jumping 2 units to the left, directed change. So in particular, rather than focusing on like where the arrow lands, like we did in the opposite view, when we were always starting at 0, right? So the key to the opposite view is you always start at 0, okay? So it actually might be better if I were to expand this explanation. So negative positive 2, where we know positive 2 is 2 units to the right of 0. So negative 2 must be 2 units to the left of 0. Whereas when we think about negative 2 as directed changes, it's 2 units to the left. The negative 2, right, represents 2 units to the left, but from any starting position. Okay. One thing that I'll say really quickly is hopefully this makes sense if you've thought about using number lines for addition and subtraction in particular, right? Because subtraction is the operation that tells you about changes in things, right? A difference between two things is like literally how much one would have to change to be the same as the other, okay? And so if I think about like having this directed arrow down here, that means negative 6 would be my ending value, negative 4 would be my starting value, right? So how much do I have to change from negative 4 to negative 6? Well, obviously it's negative 2, but if I were to capture that mathematically, right, I would have negative 6 take away negative 4. Well, that is negative 2. Right? Or over here, where I've got 5 to 3, my ending value is 3, so I'm looking at 3 take away 5, negative 2. Okay. Cool. How do we feel? So those are the 3 different views that we have for signed numbers. Now, obviously, we can reverse all of these. So now, if I were to go back and say, okay, how do you think about 3, positive 3, using the opposite view of integers? What would you say? Careful. I'm asking you to tell me how to think about positive 3 using the opposite view. So positive 3 is the opposite of negative 3, where we're thinking about negative 3 as 3 units to the left. So positive 3 must be 3 units to the right of 0. Right? So the real key there is the changing of direction. Right? If I know that positive 2 is 2 units to the right, then negative 2 must be 2 units to the left. So to the right of 0, to the left, that's what's key, right? Okay, if I asked you to tell me the meaning of positive 3 using the additive inverse view, what would you say? Can you say that louder?
Oh, yeah. 3 is the additive inverse of negative 3
Okay. Yes. So positive 3 is the additive inverse. Of negative 3, because negative 3 plus positive 3, right, is 0. So if you were to draw your picture, you would go negative 3, and then what do I need? What arrow do I have to draw to get back to 0? This arrow, right? Well, that arrow is positive 3. Are we getting it? And then positive 3 as a directed change. How would you describe that? Yeah, we're thinking of positive 3, as a change of 3 units to the right, starting from anywhere. So it could be starting, at negative 5 this way, or I could start from negative 3, whoops, too far, to here, or I could start, from 3 to 6, right? Directed change. Okay. What do you think? Good? Okay. So, now we have a way to think about signed numbers. Now we want to do interesting stuff with them, like add and subtract them, right? So we have a new set of numbers to work with, so let's talk about what operations with those numbers look like and how we can think about those operations using these numbers. Okay, so we've expanded our wheelhouse now to include basically all real numbers, but we'll focus on integers at the moment, okay? So, in other words, even though I have an entire number line here that technically captures every real number, the ones that we've highlighted are the integers. Right, so all of your negative whole numbers, 0, and positive whole numbers are, like that collection of numbers is called the integers. Okay. Whew. So, now what we're going to do is focus on how to think about adding and subtracting signed numbers. Okay? And we're going to, in particular, do this from the perspective of like what kids actually do. Okay? So I want you to think about you're a kid for a second and you've never seen a negative number in your life. Okay? And you're just now trying to figure out, and somebody says, hey, there's these things called negative numbers. Do something, right? Like what kind of meaning can you make from that? Well, one way of thinking based on what I was just doing with the number line. Notice what every time I was drawing on the number line, I started somewhere and I changed by some amount and then I landed somewhere, right? So when I think about how to work with a number line, I basically have a starting value and then I can either add or subtract to get to an ending value, right? So you can capture that information in this way if you're thinking about having an addition or subtraction problem. Is everybody cool with that? Okay, so let's now see. Well, okay, could you tell me then, using that way of thinking, how would you on a number line do this problem? -5 minus 4. So if I want to draw a number line to help me decide what to fill into the blank box. So what do you want me to put on my number line? You want a 0? Okay. Then what do you want? -5? And then what? So here's my starting value, right? Starting point. And then what do I want to do? I want to take from this starting point, it says subtract 4. William says that means I should move 4 to the left. Do you agree? Yeah. So when you subtract 4, that translates to move to the left 4 units on the number line. If you add 4, what would that have been? Move to the right 4 units. I wonder if that ever gets harder. Oh, what if I said subtract -4? Okay, we'll get there. Don't worry. No panic attacks. Okay. Can this way of thinking be tricky? Well, probably, yeah. So in particular, if I give you this number sentence, which would be, by the way, remember, a great number sentence to give to students. So blank plus 5 equals -2. Why is this a really nice number sentence to ask a student to fill in? Do you remember what my pet peeve was about notation and writing mathematics? There's something that people abuse. People abuse the equal sign, right? Because, yeah, okay. So one of the ways that it gets demolished in children's minds is that we always make problems where it's number plus number equals blank. Number minus number equals blank. Number times number equals blank, right? And so then the equal sign becomes this oh, that just means I do something symbol, right? Equal sign means do operation. But that's not what it means, right? It means this thing on this side should have the same value as this thing on this other side. And so having a number sentence where the blank is on the left is a nice way to remind kids of that meaning of equality, right? Equal sign. Okay. Well, okay, maybe you just want to see a kid doing it. Maybe that'll help you figure out why it's tricky. So let me show you some kids doing this. Hi, Violet. We want to learn from you. Did you see it? So she saw there?
Change those two into negative.
What if we couldn't change them? What if this was the problem just as it was? Can you think of any way to do that?
Did you hear the first thing she said? What did she want to change to a negative?
Oh,
So the equation she's trying to solve right now is plus 5 equals 3. What did she want to change to a negative? She wanted to change, so when she says, so remember, this is where we as grown-ups know that we have precise vocabulary for how to talk about things, but kids don't necessarily latch onto that right away. So what she's actually talking about isn't positive versus negative. What she's actually talking about is addition versus subtraction, right? And so she wants to change this addition sign to a subtraction sign. Why would that be? So, right, if you add 5 to something, how do you get a smaller number than 5? Right? This is her issue. Remember, kid hasn't formally done signed numbers yet, right? So she's grappling with this. She's trying to figure this out, okay? So do you all see that? That's why okay, that's what just happened. Moving on.
What about the number line? Does the number line help you?
-2.
Oh, that's interesting. Tell me how you're thinking about that.
First I tried -5 and -5, that would be 0. And then -4 minus 5 would be 1. -3 minus 5, that's 2. And negative. And then finally I tried -2 minus 5, and that equals 3.
So what was she, okay, right. So she was using minus when, what was she actually doing? She was adding. Okay, she was being videotaped doing math. Okay. But what was her strategy? Did you see what she was doing? So she had the number line in front of her with all these tick marks. Because there's 0. And what was she doing? Guess and check. Right? Why do you have to guess and check if your way of thinking about this is, I have a starting, the way of this is that I have to move 5 to the right from to land at 3. You don't know where to start. So she was trying different starting positions and counting 5 to the right to make sure that she eventually landed at 3. Perfectly legitimate thing to do, right? But it is one of the constraints of this way of thinking. But again, I'm not saying it's a bad thing to teach people. I just need you to acknowledge that it does have some constraints, okay? Do you want to see Violet do another one? Whoops, too far. Here's Jacob. Okay, so now Violet is going to solve the equation 2 minus something equals 6. Why is this again? Why should this feel hard to her? The answer is bigger than the starting number, and we're subtracting. Weird, right? So, okay, let's see how she handles it.
Can you read that one out? 2 minus blank equals 6. That counts.
I know. Should I try that out a little bit? Is that better? Okay.
you say what you have? What answer you got?
-4.
Now, how did you come up with -4? Where did that come from?
Because once it goes, the other a negative number to me when you're adding or subtracting it.
Mm-hmm.
It goes the other way that you want it. That it usually goes to the positive number.
Okay. So with the positive number, if you're subtracting, you would have gone.
To the left.
Okay. And so now with the negative number, and you're subtracting.
Right.
That is really interesting.
So what is her way of thinking? She's like extending this idea of negatives as opposites to when I'm doing the operations of addition and subtraction, I now do the opposite of what I would do with regular numbers. Right? Did she use regular numbers or did she say positive? She did say positive? Okay, there's a kid on one of these videos who calls them like regular numbers. I think that's adorable. Okay, so, but yeah, right, so, okay, so not only can you think about the numbers themselves as going in opposite directions, but when you combine that with an operation, you do the opposite process, right? So if I with positive numbers, right? If I go to the right when I'm adding, then with negative numbers, I'll go to the left when I'm adding. And if I'm subtracting a positive number, I normally go to the left. So if I'm subtracting a negative number, then I'll go to the right instead. Okay? Cool? You want to see one more? So good. Jacob. Jacob is in first grade, and he wants to add -5 and -2. That's what he's going to do. -5 plus -2. Okay?
Something interesting to me. You said if you had -5 plus -2, what did you say your answer would be? -7. And how are you thinking about that, James? Can you tell me how you were thinking about that?
Because like 5 plus 3. So like if you do negatives, it's like the same as 3 or
Negatives. It's like the same as, he's the one that said regular numbers. So what did he do? He was like negative plus negative. It's going to be negative, basically. So I might as well just pretend like they're all positives and throw a negative on the end. Will his strategy always work? Oh, darn. When is he going to have a problem? When he's adding a positive and a negative, right? Because now if he treats, right, so you ask James to do -3 plus 5, and he just treats everything as if it was positive, he's going to do 3 plus 5 is equal to 8, right? And then maybe decide that it's -8. I don't know, right? Okay. There's one more. Oh, God, we just never have enough time. But I still have 2 minutes, so don't leave yet. We're basically going to have to finish this on Tuesday. And then we'll start the number theory stuff. And you'll give me your gift of numbers stuff. And then the following Tuesday, we'll take our last quiz. The Tuesday of the last week of school. Like, do you guys realize we have 3 days of class left? Whoa. It's crazy. But I want to remind you, some of you have not collected your midterms from me. So you should at some point. Or if you wanted to talk to me about them, you should do that. And also, I just wanted to, well, I don't know if I can do this in a minute. I want you to think about something, especially like maybe over the holiday break. I really genuinely want you to think about why you're becoming a teacher and what you hope to give kids. Like, what can you provide for kids? And what do you hope that they come out of their educational experience possessing? Like, what kinds of mindset and mentality? Like, do you want to foster curiosity and creativity and ingenuity and like independence, but also the ability to communicate? Like, what are the things that you want kids to come out of their educational experience with? And I want you to identify those things and then acknowledge that if you're not treating your own education in that way, there is a huge disconnect, right? Like, if you can't walk into a college classroom and be curious and be willing to grow and learn something new, then what the hell are you doing trying to become a teacher? I genuinely mean that. That worries me, okay? And so I'd like you to just like ponder on that a little bit. And hopefully that'll make your last week and a half of this quarter feel a little different. And certainly the remainder of your college experience, I hope, right? It's a privilege that we're here. I hope you guys see that, right? Like, we get to spend 40 hours a week thinking about new things. That's a privilege. And I hope you feel that way. Okay, that's what I'll say.
Okay, your office hours are from 1 to 2
Oh,
today,
shit.
right?
Except because I... Okay.
So she gets out at 12:45. Like,
Okay.
I have to be there to pick her up.
All right. So you want to schedule a meeting to meet like Monday or Tuesday next week? Is that something? I'm not